Kirchhoff laws. Kirchhoff current law states that algebraic sum of entering currents और अ क्लोज बाउंड्री ज़ीरो, क्लोज बाउंड्रीज हैं, इसके अंदर हमारे पास एंट्रिंग जो करंट है वो ज़ीरो होगा. एंट्रिंग करंट बेसिकली हमारे कुछ करंट्स एंटर होंगे, कुछ करंट्स हमारे पास लीव कर रहे होंगे, तो हम इन सब को क्योंकि जो लीव कर रहे होंगे वो हमारे पास पॉजिटिव होगा, जो एंटर कर रहे होंगे वो हमारे पास नेगेटिव होगा. इसको वाइस वर्सा दोनों ले सकते हैं, कोई ऐसा मसला नहीं. तो इसका सम होगा वो हमारे पास एल्जेब्रिक सम जो होगा वो ज़ीरो होगा. सिमिलरली वोल्टेज, Kirchhoff law voltage law states that the algebraic sums of all voltage around the closed path or a loop is zero. तो हमारे पास जो वोल्टेज होगा वो क्लोज पाथ के अंदर उसका जो algebraic sum होगा वो भी जीरो होगा. लेट्स टेक एग्जांपल 20 वोल्ट्स. सो VI एंड कैलकुलेट करना है हमारे पास, जिसका इसलिए हमें डिफाइन किया गया है क्वेश्चन के अंदर ही कि हमारे पास वोल्टेज की जो पॉजिटिव नेगेटिव है वोल्टेज के वो डिफाइन किए गए डायग्राम में. तो हम इस लिहाज से सॉल्व करेंगे. तो ये फर्स्ट -20, द सेकेंड दिस वन इज V is equals to 2I, the current flowing from I from here, so it becomes V is equals to 2I, V2 is equals to 3I, V2 is equals to 3I. so हमारी जो लूप जो डायग्राम बनेगी किर्चॉफ वोल्टेज लॉ, क्योंकि ये स्टार्ट फ्रॉम नेगेटिव है, this is positive, this become positive, and this enter from negative, so it also become negative, so negative V2. So -20 plus V1 minus V2 equal to 0. so हमने इसकी जगह V1 की जगह 2I पुट कर दिया, V2 की जगह 3I पुट कर दिया, जो हमने so it become 5I, and -20 V moves to the right side, becomes +20, so I becomes 4 ampere. so we again put it 4 ampere here, so 2 into 4 becomes 8 volts, and 3 into 4 becomes -12 volts. so ये डिफाइन कर रहा है कि जो हमने जो क्वेश्चन में हमें साइंस दिए हुए हैं, प्लस माइनस के जो साइंस दिए हुए हैं वोल्टेज के, वो अपोजिट है. बेसिकली एक्चुअली इसका साइंस जो है वो प्लस माइनस है.
In this example, we can see this is a 12 volt and the current flowing from this side. So this is the source, the current entered from the minus side, so we can say that this is the -12. Then for the resistor we always consider as plus minus, so we say that the voltage across this one becomes 4I plus 4I, and the voltage across this one, this dependent source, is entering from the plus side, so it becomes 2V0, and the current entering from the negative side, so it becomes -4, and from this side we can say that this is minus V0 equal to 0. As we know that V0 is because the current is entering from the negative side, so we say that the V0 is -6I. The current is negative and the ohms is 6 ohms, so it becomes V0 is -6I. So when we put the -6I here, it becomes +6I, and when we put the -6I here, so it becomes -12I. So -12 and -4 is -16, and -4I or +4I and 6I is 10I, and 2 minus 6I is -12I equal to 0. So when we solve this, so it becomes 16 moves to right side, plus 16, so this is -2I is equals to 16, so I becomes 16 by -8. so we can say that So we can say that I is equals to 16 divided by -2, which is -8 amps. So when we put -8 amps in this equation, so we found V0 is equals to minus minus plus, and 6 8 is 48, so V0 is 48 volts. In this example, we apply Ohm's law first. So across this resistor, the voltage V1 will be is 8I1. So let's say we say that this is the I1 flowing from here, so we say that 8I1. For V2, we can say the I2 is here and 3 is this one entering from the plus side, so it becomes 3I2. This is I3 and it's flowing from entering from the plus side, so the voltage V3 is 6I3. So we apply the KCL. When we apply the KCL, so KCL apply on nodes. So entering is positive, leaving is negative in this case. So I1 is positive, I2 and I3 are leaving, so we say negative I2, negative I3 equal to 0. For when we apply KVL at loop 1, so minus 30 plus V1 plus V2, minus 30 plus V1 plus V2 is equals to 0. For this loop, minus V2 plus V3, right? Minus V2 plus V3. So we apply KVL at loop 2, so this one. So when we simplify this equation, as you say that, let's suppose this is equation 1, let's suppose. So we can say that when we put V1, what is V1? V1 is 8I1. What is V2? Is 3I2. So we replace V1 with 8I1 and we replace V2 with 3I2. And then we simplify this equation in terms of I1. So this one, minus 30 moves to the right side, becomes plus 30, and the plus 3I2 when we move to the right side it becomes minus 3I2, and then because it's 8I1, so we can say this like this. It's like this: 8I1 equal to 30 minus 3I2. Okay, so 8I is multiplying with I, so 8 is multiplying with I, so we move to the right side, so it becomes divide. So we can say that 30 minus 3I2 divided by 8. So this is, we can say this equation 2. When we apply KVL at loop 2, as we discussed earlier, so for this we get this equation, but from this equation we can find that when we move the V2 on the right side, so V2 equal to V3 or V3 equal to V2, same as vice versa. So we can also say that V3 is 6I3 and V2 is 3I2. So we have this equation, so we can cancel it out. So I3 is, we cancel out 3 1s are 3 and 3 2s are 6. So we divide the 2 from here to here, so I3 is I2 divided by 2. So we have this equation. Now we have I3 equation, we have I1 equation. So because what we are trying to do, we are trying to eliminate, we want to eliminate I1, we want to eliminate when we put I1, so we have this equation, and we have this equation for equation A, we want to eliminate I1 and we want to eliminate I3. So we have the equation of I1 in term of I2. As we can see here in equation 2, we have I1 in term of I2, right? So we have the I3 in term of I2. So there is only one variable when we put I1 and I2 in equation A. So we can see that 30 minus 3I2 divided by 8 minus I2, and we have minus I2 divided by 2. So we have only one variable, which is I2 in this equation. So we can find that to find the I2, we take LCM first, and when we take the LCM, So we have 30 minus 3i2 minus 8i2 minus 4i2 divide by 8 equal to 0. So we can say that this 8 multiplied by 0 is becomes 0. So we have 30 minus, so we have 3 plus 8 is 11, and then 11 is 15. So we have 15 i2 equal to 0, and we can say 13 is equals to 15 i2, and i2 will becomes 30 divided by 15, which is i2 is equals to 2 amps. Can say I2 is equals to 2 amps. So once we got I2, we place I2 here in equation 2. So we have 30 minus 3 into 2 is 6. So 30 minus 6 is 24, and 24 divided by 8 is 3 amps, right? So I1 is 3 amps. So when we put 2 amps in equation number 3, so we can say that 2 divided by 2 is 1 amps. So this is I3 is 1 amps. When we have I1, I2 and I3, we can also find V1, V2 and V3. So I1 is 2 amp, I1 is 3 amps. So 8 3 is 24. So V1 is 24 volts, and V2 is equal to 3 into I2, and I2 is 2 amps. So 3 into 2 6 volts, V2 is 6 volts. V3 is 6 into I3, and I3 is 1 amps. So 6 into 1 is 6 volts. So we have 24 volts, 6 volts and 6 volts. And as you can see also here that this one and this one and this one is in parallel. This is why we say that V2 equal to V3. So when we have a parallel nodes, we have the same voltages. So we have exactly the same voltages as the rules. So you can see also, we can also see this V2 equal to V3.